Hey everyone, good afternoon. It's Ryan. And in this video, I'm going to be doing my second contribution of week 4. And for my second contribution, I decided to go over the propagation step. For my first contribution, I went over the initiation step. So propagation is just the next step in the process of radical halogenation. And this question asks, which of the following is a propagation step in the free radical chlorination of methane? All right. So, one thing that I like to do to break down hard concepts and make them simpler in my brain is to, instead of think about all the exact rules and naming and complex machinery involved, I try to dumb it down to a simple, funny story. A story that will stick in my head. And that way, even though it is a complex situation, I can go back to that story that is so simple that even a grade schooler can understand it, and that helps me to remember it later when I'm taking a test or trying to remember what I learned. So with that in mind, I'm going to tell you how my brain thinks about propagation, and maybe it'll be helpful to you. So the text says the chlorine radicals produced in the initiation step, which we went over in the last video, are very unstable. All right, so in the initiation step, we created a chlorine radical from Cl2 being cleaved and light breaking a bond and creating two Cl radicals. So right now, what we have is a chlorine that broke up with its other chlorine. They had a long relationship, very sad breakup. They decided to split all their material items in the world, and this chlorine got to take one electron with it, and the other chlorine not shown takes the other electron, but neither one of them are left whole. They both have a missing electron with it. So this chlorine is wandering around the world trying to find another electron to kind of make it whole. And it comes across a molecule like this that has a hydrogen. And this hydrogen and this chlorine fall in love. And this hydrogen says, sorry, molecule, I'm breaking up with you, and I'm taking my lone electron with me. So this hydrogen says, whoop, comes over here, takes its lone electron, and it donates an electron to the chlorine. The chlorine, donates one back, kind of thing, and they create a bond together, which we go over here, becomes HCl. And now it's happy because it has no radical left. However, this guy right here, this molecule, whose hydrogen left the nest, is left without one of its electrons too. So the one electron that is left from this bond goes onto the carbon, which you will see right here. That's why the radical is right here. And that is the propagation step. Unlike the initiation step, which I talked about, where we go from 0 radicals to 2, in the propagation step, we go from 1 to 1. We're not losing any radicals. We're not gaining any radicals. We're just transferring them between different atoms. So chlorine had it. It fell in love with hydrogen. And hydrogen left with its one radical, came over here, created a bond that became HCl. And now carbon is stuck with the heartache of having that leftover radical.